Let's start. So this is a demo only session. I have no slides, and the idea is to do some basic about SQL. And what I will do is that I will start with NoSQL, because today many people are talking about NoSQL. And I will start with that to introduce the relational database concepts and the SQL concepts. My idea is to introduce it in the same way when 40 years ago SQL came, and today, if people started with NoSQL, they can learn a bit more about it. And even if you already know SQL, you probably will learn a few things. So I'm Franck Pachot. I'm a consultant working in Switzerland at DBI Services. I'm doing consulting, I'm doing trainings, and I'm working with Oracle for quite a long time. I'm an Oracle ace. All the demo, I will do it on an autonomous database in the free tier. So all what I do, you can do it yourself for free. And at the end, I will provide you a Jupyter notebook that you can also run as you want. So full exercises to reproduce the same thing later. I'm doing that on the Oracle Autonomous Database because I start with NoSQL, but Oracle is a converged database and has also NoSQL APIs. Let me show you directly. So I'm connected here with SQL, but for the moment, I will start with Python, in the idea that before SQL, or in NoSQL, your interface is a procedural language like Java or Python or anything. So I'm starting with Python. It might look strange that I start to show NoSQL before SQL, but if you think about it, before SQL was invented, people were doing NoSQL, even if it was not with this name. So from Python, if I want to connect to an Oracle database, I use 6 Oracle driver, and I connect with a name, a password, and a service name. And I create a SODA database. This is SODA is a simple Oracle document API. It's like a NoSQL API, you know, a key value where the value is a document, a JSON document usually. So the idea is to access with a key to a document that can have any structure. That's the idea of NoSQL. Okay, then with this API, I can create a collection. In NoSQL, there are no defined name, but usually a set of items that you store is a collection. I create an employee collection and I will put some items with SODA. I do that with create document. And I put some information like employee name, job name, anything. If you are used to Oracle Scott Tiger examples, I'm working with the same set of data there, just creating not in a relational table, but in a collection with SODA interface there. We will see that finally it goes to a table, but the interface for the moment is not SQL. It's NoSQL-like, just putting JSON like this with a key that I've defined. I've defined the employee number being the key, and this is the key. Okay. I commit. Some NoSQL databases do not manage transactions. This one with SODA is backed by a relational database where you have to commit your changes. And if you want to look up some data from there, you have a find in the SODA API where you put queries like query by example, QBE. Here, I'm just looking for employees in the employee collection where manager does not exist. And then if I print the result of that, I see King, it's the only one with no manager just because he's the boss. So this API is very simple, this Soda API, but simple like any NoSQL API. You put items in a collection, you access items with a key or with some query, and this with query by example is quite easy. I did that from Python, but in SQL the command line from SQL developer, in SQL you can also have some Soda commands. I can list all the collections I have. Here I've created the employee collection. I can count the number of employees. I can also query it with this query by example. I query things like employee name being Smith, and then it shows me the key of the item and the full content of the document, the JSON thing that I have behind it. I can also query it directly with a key. So very simple API. And today, many developers like this NoSQL API. Just because it's easy, they don't have a lot to learn, just a few commands, find, put, get, anything. And they do that from the procedural language, which they like. Now, I have a collection with employee names, and I want to put some more information because my data model, my database system evolves. And then from this command line, I'm doing a replace with a key, and I'm just putting more information because it is JSON. You can embed more information nested within the item. I put the department information for each employee. I will put a department number and department name and the location, which is Dallas there. I will do that for all of them. So now my data model is still a single collection with employees and information about the department they are working in. Let's query one location. So this is the kind of query I can do with a query by example. Get me the employees, which are like department location being New York, and I see that I have 3 employees there. And there you start to see the first problem with NoSQL, with or the problem they had before the SQL and the relational database approach when storing things like that in files. The problem here is that the department information is duplicated in each employee. Department 10 is accounting located in New York. Then what happens if the department moves, like being still accounting, but in another location, like San Francisco? Then I will have to update all concerned employee to say that it's not anymore New York, but San Francisco. And this is more work, so performance issue, scalability issue, but also there is a high risk of inconsistency. For example, if I just update the 2 first one and not the last one, my problem will be that some information are telling me that accounting is in New York and some other will tell me that it is in San Francisco. So how can I avoid this, those duplicates and this risk? In a hierarchical structure like JSON, like all the structures you can have in NoSQL, I can inverse the hierarchy. Instead of storing for each employee a department, I will store departments with a list of employees. There is also another problem with what I add there. What happens if I create a new department in my company before having employees in it? I just cannot with this structure. So now what I will do is create a department collection. And I will insert departments. So I insert department 10, accounting in New York. And for this department, I add nested information about all employees. This in JSON is a set. I have first employee, King, second employee, Clark, and I have the list. So with NoSQL, before the relational databases, you can store hierarchies, but you have to decide in which way you will navigate them. I had some problems when I decided to put detail about department within an employee collection. Now I'm doing the opposite. I have departments and everything in it. Okay? Then I will create all of them to get the same information basically. And there I can also create an empty department, department 40, has no employee yet. So this data model is quite better for other use cases that were not possible with the other model. But the problem is that I must have to decide how I will use the data. And that's what happens today with NoSQL. In one sense, it's agile because you can put whatever you want in a document, but it's not agile in the sense that you need to know exactly all the different access paths to your data. Okay, let's query this. I can query department with a name, accounting. I can query department located in New York. I see accounting and the employees there. And I can also even query a department having an employee named King. Looks good. But for the moment, I have only a collection. If I look at the execution plan, and that's something I can do here because I have a relational database behind, even if I'm using this Soda NoSQL API, I can see that I am basically doing a full scan on this collection. If I want to look for a specific location, for example, I may want to index it. And that's something that is possible even in NoSQL. I'm still using the NoSQL API, but I'm introducing the relational databases concepts like splitting the collections and creating indexes. Back to Python, I just open the collection department and create an index in it, which I call my index on location. And I define the path to the index because it can be on something that is nested within the documents. And now if I query for a department location, exactly the same as before, I can see that I'm doing an index range scan. Okay, so that's fine. That's convenient when I want to access to employees by department. But if I want information only about departments, like location New York, I will have to fetch all information about employees, which I do not need. And also the same as before, if I want to enter an employee in my system without any department, I cannot because everything is in a department collection. And now I'm introducing another concept in relational databases. I'm still doing it with NoSQL collections, but the idea is to split what is a different business entity, what is a different business object, split it to different collection, and we will see in different tables. So for the moment, I'm dropping this department collection to create a new one, which will hold only information about departments. In relational databases, you can read a lot about the maths that are behind normalization and the normal forms. But for the moment, you can just stick with the basics, which is department is an object by itself. And then you need a specific table for it. And so I have departments. I can query a department for department 10, for example, and I have only information about departments. And now what I will do with my employees, so the collection I had before, employees with department information, I don't need anymore to duplicate in each employee the department name and the location. I just need the department number because all information from one department number is in the department collection. So this is what I will do here. I will replace information for King with just the information about the employee and just the department number. And then my application will, if my application needs only information about employees, I query employees. And if I need to know more information about department, I will fetch the department number and then query the department collection to get more information. So here you get the idea behind having multiple tables rather than a hierarchy in one document. I'm doing that for all employees there. So that was an introduction with NoSQL API, the SODA in Oracle database, but it can be any NoSQL. It's the same idea, and you can choose to split in multiple collections what you may have in a hierarchy in one document. I am working here on the Oracle database, and even if it provides a NoSQL API, it is stored behind in relational databases. So I can just query for the DDL of my department collection. Which takes some time. I don't know why, but basically it calls DBMS metadata. I can see that behind my department collection, which has a key and information, department number, department name, and all that. So behind that, sorry, behind that, I have a table, a relational table with an ID that is just generated. It's a UID, but I can choose, for example, in the employee collection, I choose the employee number, information, some metadata about when the document was created, version, and everything else is stored as JSON. That's usual in a NoSQL database. You put all information as attributes in a JSON document. And here, JSON is format OZone because I'm on an Oracle database. And rather than storing the JSON as is, as text, they have a specific format. Here, I'm running on 19C, the autonomous database. They have this format. And you may have heard that in the autonomous database, you have three types of database, one for data warehouse, one for OLTP, and one that is much cheaper to store mainly those kind of things, JSON for NoSQL API. Indexes because it's a table in behind, and you see that this document is stored as a blob, a binary large object, and but with specific format. So if I do a described just to see the column, you can see that I have an ID. I have the flexibility of semi-structured NoSQL. Everything is put in a JSON document, which means that I can have different attributes for different departments if I want to. I can query the DDL for employee. It's kind of the same. Everything is stored in a JSON document, a blob in format OZone. The only difference when I created it, I mentioned that I wanted the employee number to be the key. That's also a concept we see in SQL databases. Sometimes for one business, so I said that for one business object, we will create a separate table. And depending on the business rules we have, maybe we have a natural key, or maybe we have to generate a key. This is what I did there for employees. I have an employee number, which I use as a key. For department, I decided not to use the department number, but to generate an ID. I see that there is a question, what are advantages as NoSQL compared to standard SQL? The idea of this session is to show you that SQL has more advantages, and this is why I start with NoSQL and I'm moving to SQL. Advantages, if you want flexibility about what you put for an item, then NoSQL is good because you store it as JSON. When I say NoSQL, it can be like I'm doing it there, JSON in a SQL database, Oracle or Postgres, for example. Another advantage of NoSQL, because this API is very simple, developers tend to like it. But the goal of my session is also to show you that SQL is not so difficult to start with. And the third thing about NoSQL, because the API is very, very, very simple, it's much simpler to implement, and then you probably have better performance with less code than a relational database. Of course, if you do not have to manage transaction, integrity constraints, and everything, it's easier to build a NoSQL database. So flexibility, but flexibility because you can put everything in a document, but you need to know in advance the access path, just because the API is simple. Okay, so now I will get rid of those collections because I see that I have a relational table in behind. I will create a real relational table to store my departments. Create table depth, but I will not put everything in JSON here. I will put columns because I know from my business analysis, I know that a department has a department number, a department name, and the location. And that's just for the moment. I can add more columns later. That's totally possible. SQL is agile. You can change the schema later if you want. So I declare the columns, and what I will do, because I have all data already in a NoSQL collection, in a SODA collection, I will query the table I had before with the JSON, and I will just transform this JSON, so that I had in my collection, I will transform it to real columns. So I'm saying that what I had in JSON as depth no, I am putting that in a depth no column. That is a number. Here, I put the data types. In JSON, you put everything as a string. You have no specific date data type, for example. In SQL, you start to give a meaning to each column. What is a date? You declare it as a date, and then you can do date arithmetic on it, and the optimizer will know that it is a date. I have a question if you want to work with JSON better in NoSQL or in a relational database. That really depends. The advantage of the Oracle approach is that they provide a converged database where you can put everything. And probably in your information system, in your enterprise database, you may have things that you prefer to store as JSON, and you may have things that you prefer to store in relational databases. But that's one approach. If you go to Amazon approach, for example, AWS, they prefer to build purpose-built databases. So you have one for NoSQL stuff, you have one for relational database stuff, and you move data between them, like microservices exchanging data. So that really depends on your architecture if you want to do everything in one database. And it also depends on the capabilities. Oracle goes very far with JSON, Postgres as well. Other databases cannot do the same thing. So this is my relational table. Now, the idea of SQL and the idea of relational databases is that it is simple, and that may look strange today because SQL became complex, and finally developers go to NoSQL because the API is more simple. But at the basis, the idea of SQL and relational databases is that it is simple and everything is displayed and may be stored, but displayed as a two-dimension table. You see, I have rows, one per department. So I map my business information departments to rows in my database. And for each of the attributes I want to store, I have columns. Everything is modeled as simple rows and columns, and that makes everything more simple. One more concept in relational databases, you do not just stick to store data, you can enforce some business rules. For example, here I'm adding a constraint telling that department number is the primary key. That you can do also with NoSQL, but you can have only one key. Here, I can also add a second key because department name is also unique. And then I can access my departments either with the number or with the name. Both are unique. And by declaring that, I ensure that nobody will be able to enter another department with the same name, which could be misleading for the application and the user. So I enforce the constraints to ensure about the integrity of my data. But I also tell the database this is unique, and then the database can create special access paths for it. For example, there is an index that is created in behind. And the other things that is often overlooked, when you declare a constraint, you know, you have this assertion that you know it is unique. And then you don't have to check it in your code. You don't have to check it when you ingest new data, and you don't have to check it, deduplicate when you query it. I see that I have a question. Which popular DBMS use NoSQL? A lot of questions about NoSQL. It's not really the topic. NoSQL were made famous by MongoDB, especially because of the easy API. Their idea was not to implement all the referential integrity, for example, but just provide an easy API, and developers are happy with that. Or for example, in Oracle, you have also a NoSQL database, a key value database, which is based on Berkeley. In AWS, for example, you have DynamoDB, so you have many of them. The problem, you have many of them, and each of them have a different API. One advantage of SQL is that there is a standard. So of course, all databases have different, some specific features and specific syntax, but there is a standard behind that. Okay, one more constraint I will add. I know that all departments must have a geographical location, and then I tell that to my database. I don't want nulls. Nulls in SQL just means either it is unknown or not applicable. I cannot enter a department with an unknown location. And what is the big advantage of that? I will show you one advantage, but the biggest advantage is that in my code, in the application, I know that if I fetch some departments, I have a location, which means that, for example, I don't have to add additional code to test if there is a null, and I have no risk to get this runtime error, not null exception in Java, for example. This is one big advantage of SQL databases. When you say this has a value, you don't have to verify in your code that this has a value, and you don't take the risk that something has no value and then get an error, a core dump, a null pointer exception or something like that. And another advantage, because I tell to the database, this is not null, it may have some optimization. For example, I'm doing just a simple select from depth, and I will show the execution plan. Let me tell you about execution plans. SQL, one additional concept in SQL is that when you query the database, you just define the result you want. This just means from depth, I want all columns. You do not tell the database how to get data or how to store it from an insert, for example. But the database will decide the best access path to the data. And then you can query later the execution plan. Here I can see that the database decided to do a full scan on debt. But now running another query, I want to know debt where location is not known. Of course, there are none of them because I know my data, but I can see that the database decided also to full scan the debt, but finally didn't do it. You see this column starts, full scan was done once to get all the department there. And here, because it knows from the constraint that there are no location unknown, it didn't have to scan it at all. So this was really fast and an optimization thanks to the constraints. Okay, I have a question about the record of the session. I will answer that at the end. So that was about constraints and tables. Let me create the same for employees, an employee table. And again, I will fill data directly from the collection I had before. You can see that in SQL, I have specific types. For example, I have a date, I have numbers. And here is what I have in employees. And employees have a key, the employee number. And I can also say that they must have a department, this department number, which references the department table, is not null, which means I cannot have an employee without having a department. And I add an additional constraint, a foreign key, which tells that this department number must exist in the department table, which is quite important. I cannot put any number there. I can just put departments that are known, for which I know I have a name and a location. So all those are integrity constraints. And you can see that I put on delete cascade there. This is to mimic what I had with this department collection holding all the employees in it. With this collection, if I removed a department, then all employees in it are removed as well. And with on delete cascade, I'm doing the same. I'm showing you that. If I query all employees, I have 14 of them. If I delete the department sales, what happens because of the on delete cascade, all the employees from sales disappeared. One big advantage of relational databases is that if you encounter an error, you can roll back and get back to the previous set. So that was to show you the on-delete cascade. If I drop the on-delete cascade to create one without the on-delete cascade, the default is on-delete restrict. If I want to delete a department which has employees, I just get an error. So this prevents integrity problems. And then again, my application knows that I cannot delete a department with employees. I don't have to add additional code. And if you imagine the code to do that, it's easy in single user use cases. But imagine how to check that you cannot delete a department when someone is inserting employees in it in multi-user situation. That's not easy. Here, the SQL database maintains that for you. Okay, moving faster to one more concept in SQL and in Oracle databases. Because I separate business entities into multiple tables, I have to join them at runtime, and that's the idea. You do not store information pre-joins in a hierarchy because you do not know yet all the different possibilities to query them, to navigate from one to the other. Some use case will need to go to department and then to employees. Other use cases will go from employees to know department information. Other use cases don't care about department, but only employees. So at runtime, you join them. And this is easy in SQL. You just mention from which table you read, employees and departments, that you join them, and you say when you join them, all the different combination, you choose only those where the department number matches. And I put an order by here to get them ordered by employee name. I select start there. One more concept about SQL is that you have actually two SQL languages. One for ad hoc queries, like I'm doing there, interactive, like a data scientist will mine on its data. And here it is perfectly okay to do a select star just because I don't want to name all the columns. But there is also the SQL that is used for programmatic interfaces that you will put in your code. And there you do not use select star. You name the columns for the simple reason that SQL is agile. Someone may later add a new column. And if you select star, then you will have a new column and your code doesn't know it. So be careful with SQL. Select star is okay only when it's interactive. If you code some statement, then name the columns. Okay, I'm back to the joins there. And with this simple structure, the big advantage is that I can see it as a whole in the simple structure. Why do I see all information duplicated there? For example, sales Chicago. This is only for the query because it's easy. If I take just one row, I have all information. I can read that as employee number 7499, named Alan, is working as a salesman. I know his manager. He has been hired at that time. He's working in sales, which is in Chicago. You can build a sentence from a single row. But the advantage of having two tables, if I rename the sales department as cloud sales, and I do the same select, exactly the same select, I still have something completely consistent. It has been renamed for all of them, just because in behind I have two tables. Okay, one question is, which DBMS did you use as NoSQL in current presentation? This is still Oracle. This is still the same Oracle that you know, 19C there. And with the Soda API, I will put all links at the end. Okay, of course, reading rows, full rows is convenient there if you want to see one row, but sometimes you want to see the hierarchy. Let me query here, departments and employees in departments. I don't want to see that repeated, for example, in a report. So here I just break on it because it is ordered, because it is sorted. I can break on it. And I can even do a left outer join. The default of a join shows you only rows that matches. You see the difference? Before I had only 3 departments because in the 4th department, I have no employees. Here, if I left outer join, just changing one thing in the join syntax, if I left outer join, I can see the department with no employees in it. Okay, and if I want to see the data from a different point of view, for example, jobs, and list of employee per job, I can do that. That's the advantage. I store data in different tables, and then I can query it with different points of view. And of course, if I want to see it as JSON, I can with a simple function, which is select JSON object. And I'm going fast from it, but if I want to build a JSON, specific JSON structure from it, I can do it easily with those functions. And I can choose one JSON document per employee. I can also print it, or everything as one JSON. I can do everything I want there. Okay, I'm looking at the time, just 5 minutes left. I will take the questions at the end, and I'm going fast to show you one important thing to know in SQL. I mentioned that SQL has two interfaces, one for ad hoc queries and one for programmatic interface. I mentioned that select star, you do that only for ad hoc queries. And there is another thing that you need to know when embedding SQL in a procedural program. Don't do something like this. Here, I'm connecting and I'm doing a select to get employee number 02, employee number 0, employee number. Do not do that in a program. That's okay for ad hoc queries, but in a program, exactly the same as a program, you write it with variables and then you compile it and then you execute it with different arguments. You do the same with SQL when it is embedded in the programmatic interface. So what I do here in Python, I put my SQL statement as a string with a variable. And then I prepare this statement, this compiles it. And then I can query it with different values. I put here in Python the values, and I just fetch each of them, and I query them and print them. Okay? I have just something else because we are near the end. I will mention where you can find more information about this and run this yourself. Excuse me, I have to quit Python. And how does that work? If I quit and put this, and I wanted to put also a QR code somewhere, maybe there, yeah. Sorry, just to display quickly what I wanted to display at the end. So the QR code goes to this URL, and there you can run a Jupyter notebook. So Jupyter is Python. A notebook is somewhere where you can put code and see the result. And it runs on Google Colab because it's a free environment and it connects to my database, but it has all credentials. So you can play with it. And this is the handout for this session. I will show it to you just at the end. Get the URL with the QR code and play with it and see everything I have shown. I just look at the last question. Is it convenient using JSON, CLOB, BLOB fields in DB, which are in replication? The same with transferring data to data warehouse? Yes, of course. When you build a data warehouse, you appreciate that your data as a structure and relational databases are good for that. Replicating big documents, that's more difficult. Okay, I think we have 2 minutes left. Do you have any question? And in the meantime, I show you how looks the notebook. If I get it there. So if you go to SQL 101.phc.net, you can see that. It seems that my screen is okay, not responding, but that's not, it works better from Chrome, but this is how it looks like. The notebook, you can run it yourself if you have a Gmail account because it is on Google Colab. And you can see the queries. I'm sorry. Yeah. So this is the setup of the connection, but you don't really care about that. If I move later, so I have put some explanation, and this is exactly what I've done in the demo. And you can also run it yourself. Huh? For example, I can, I didn't initialize that, but you can run it yourself. It connects to my autonomous database, which I share, and you can play with it. Okay, we are just in time. tell me if...
Thank you, Frank, for your interesting presentation and practical and useful live demo.
Okay, thank you very much. And do not hesitate to reach me on Twitter or email.